Okay, so a lot of you folks have had questions about the optimization problems. So let's just do one and see what happens. This is kind of like the question from your worksheet. Find two positive numbers whose product is 9 and has the minimum sum, or something like that. Um, so I'll kind of walk you guys through it step by step, um, with one hand holding the camera and one hand writing something. All right, so first thing is you're going to need to make a primary equation. Okay, primary equation is always the function for what you're trying to optimize. And remember, whatever you're trying to optimize is whatever you're trying to find the min or max of. So in this case, we're trying to find a minimum sum. So that's what we're trying to optimize from these two numbers. They're not going to give you any function, so you're going to have to kind of come up with one on your own. I saw a lot of people write something like x plus y equals z or something like that. It's really up to you, um, in terms of which letters you want to use. I would just go with something like s equals a plus b, something simple, right? Because obviously s is the sum, and then your two positive numbers are a and b. And then, so this is your this is your primary equation, and then you need a secondary, also known as the constraining equation. It's the constraint that is put upon these two values, because if you just said, oh, find me two positive numbers, minimum sum, they could be any two numbers, and or they would be like the smallest decimals or something. So the constraint is that these two positive numbers have a product of 9. Usually, it's a constraint because they give you a value attached to it, kind of like when we had our box, when we were cutting that box, and we only had a limited amount of paper to use. Yeah. Yeah. Okay. So we know that these two numbers have a product of 9, so we'll set that up. That means A times B should equal 9. Okay. So that's our secondary. So we have a primary, we have our secondary. Our primary tends to have more than one variable. So we're going to go for the secondary and we're going to solve for one of them. In this problem, it doesn't really matter which variable you solve for, it doesn't matter which variable you isolate. But later on, you might kind of start seeing some problems that's like, it'll kind of, nudge you towards a certain variable to solve for. Because it's easier, or maybe because the primary, whatever, you'll kind of see which one it is based on just what you experience. So from here, we'll just solve for, I don't know, let's just solve for A. So we'll divide B to both sides, and then we get A equals 9 over B. There's my cat. Okay, so A equals 9 over B. So from there, we're going to take that and we're going to sub it into our primary. Hello. So, okay. So, A equals 9 over B. We're going to plug that in there for that A. So we have S equals 9 over B plus B. That's kind of hard to... 9 over B plus B. Okay. From here, we're going to derive, right? Because when we derive, we're going to try to find the critical number. Critical numbers get us extrema, and extrema will be minimum or maximum, and that will be helpful because remember, we're looking for the minimum of our sum. Okay, we might end up with a maximum as well, but of course, there will be steps later on to fix that. So from here, we can derive, which I saw some people have trouble with today. So before we do that, let's rewrite it. S equals 9b to the negative 1 plus b. That's just a rewrite first, okay? And from there, we're going to go ahead and derive. So we're going to derive with respect to b. Some people wanted to just put s prime. Other people wanted to get more specific and say it was ds over db. Okay, just to remind you that you are deriving with respect to b, equals, and then this becomes negative 9 b to the negative 2. Okay, and I know we're a little rusty because I saw some people want to use quotient rule here. Some people want to use product rule here. It's just a simple power rule, guys, all right? So don't overcomplicate things if you don't have to. And then derivative of b is 1, okay? So that's our derivative. Let's rewrite it because it's not very cooperative right now. It's going to be negative 9 over b squared plus 1. Okay, and then that is still not cooperative. It's a little difficult still to kind of get the actual answers that we want. I know some people want to set this to 0 and subtract 1. There's a problem with that. So let me just show you how I would handle this. So we can set it to 0. Actually, no, don't even set it to 0. We'll keep it as ds over db equals. And then I'm going to combine this into one fraction. This is still negative 9 over b squared. And this is going to be b squared over b squared. Okay, right? So we have common denominators. Okay, and then that becomes negative 9. I'm going to rewrite it as b squared minus 9 over b squared. So we've basically combined it into one fraction. And from here, this is still ds over db, all right? From here, to find a critical number, we have to set our derivative to 0 and undefined, because you never know what happens when it's undefined. So in order to make this derivative a 0, we would have to set our numerator to 0, and then we solve that out. And b squared minus 9, this becomes b plus 3, b minus 3 equals 0. Therefore, b equals plus and minus 3. And then in order to make our derivative undefined, we will set the denominator equal to 0. B squared equals 0, which of course just means b equals 0. So we have 3 critical numbers. Now that you have 3 critical numbers, the next step in this optimization thing is to put it into, to find out your feasible domain, which is basically like if it makes sense. If you recall from our cutting problem, we could theoretically cut 4 inches from both sides or whatever it was, or 8 boxes from each side, but that would effectively cut the whole paper in half, which would give us a minimum because there's no volume, you know? So it doesn't really make sense. So remember, all the way in the beginning, find 2 positive numbers. And if you look at our critical numbers, we have negative 3, we have positive 3, and we have 0. 0 is not a positive number. Okay, it's not. Negative 3 is not, so that means the only option here is just b equals 3. Okay, so we found one answer. You're not done yet because remember, the question is asking for 2 positive numbers. So what do we do with this? I know it's kind of easy for this problem, but the actual procedure is to take this b equals 3 and plug it back into your secondary equation to find your other number. Okay, now like I said, in this problem, it's super easy. It's like, well, if one of them is 3 and its product is 9, then that means the other guy has to be 3 also. But later on, you'll see why it's important to follow the procedure of plugging it back into your secondary equation. So you get a equals 9 over 3, which of course a equals 3. And then from there, this is a word problem, so make sure you write it as a word answer. The 2 positive numbers are 3 and 3. Yeah? Okay. Text me if you have questions. Okay, bye.